Yo, what's up, guys? Today I made a machine learning model that can play Flappy Bird. So first things first, had to make the Flappy Bird game itself. This is the game loop, and I actually didn't make this myself. I got it from YouTuber online called Kenny Yip Coding. He explains how to make the Flappy Bird game using Pygame, the Pygame library. Pretty helpful video. I recommend you go check it out and check out his channel. And then so once we have like the actual game and everything set up, first thing I wanted to do was collect data. So I didn't just collect everything on the screen, because when it comes to machine learning and AI, when like data, you can't just like throw in data, because data quality is better than data quantity. So quality over quantity in this case. So first of all, we obviously want to know where the bird is. This is where the bird is. Like the machine learning model would like to know where the bird is, and then it wants to know how fast the bird is falling. So bird velocity is just basically how fast the bird is falling or how fast the bird is rising. That's basically what that is. So we want to know that. Then we also want to know how far away it is from the next pipe. So obviously, so when you play the game, machine learning has to know that when do I jump, how far away is the next pipe, so I know when I jump. That's kind of how it is. Then the vertical error is how high is it, or how far away is it from the gap that it has to go through. So if it's like, it could be higher than the gap, it could be lower than the gap. It needs to know so it can adjust itself to get to that position. Then the next thing that we have is the gap position. Obviously you want to know where the gap is, and then the action is whether it jumps or not. That's just 1 is jump, 0 is don't jump. So I just made a dictionary that can collect all the data that we need. And then the way I did it was I created a function called collect data, and all this does is just, as you play, it collects the data, it puts it in the dictionary, and then you just play like normal. And then after you play and you press, you press P. This means if the P button is pressed, it will save the data into a CSV file, and it'll print out the shape and the first 5 parts of the data. And then, so if the game is not over, it will collect data, keep putting it in the dictionary. And then the reason I did this part right here is because if I did it the other way around, I believe the problem I was having was that it would jump every time the velocity was negative 5.6. So the machine learning model actually found that correlation and said all the other variables are unnecessary, and decided that it would only jump when the velocity was negative 5.6, which rarely ever happens. So that was like the actual data flaw, and it spent hours bugging that. So I decided to do it this way because I actually updated the velocity here. So when you jump, it updates the velocity, but this time I made the action 1, and then if the action is 1, it will update the velocity after we've collected the data. So it makes it better for data collection. Honestly, the hardest part about all this was probably the data collection. So after we get our CSV file, we can take a look at what the data looks like. So yeah, it's a lot of data because I'm busy collecting 60 points of data per second, because we're running this at 60 frames per second. So it collects all the data, and then you put it into, what I did was, now I can create a model. I split my data into X data and Y data. So the y data, the output we want is for it to know when to jump, which makes our action our y, and then everything else our x, right? So we now split our data into train and test data using the train test split function, and then we create our model, which is just basically an object with we use random forest classifier because we want to know whether it jumps or not. It's two things, so we just want to classify 1 or 0. Basically, we just want to know when to jump or not. That is basically it. And then for these n estimators is just basically the number of trees it has to go through. Actually, let me go back a bit before we actually go into the hyperparameters. Let's talk about how the random forest classifier works. So the random forest classifier is basically just saying that I am going to make a bunch of trees, and each of those trees will take those data and ask different questions. So it's basically like a data structure, a tree data structure, and it's just going to be like, if we look at the data, it's going to be like, oh, is bird position greater than the vertical error, greater than the gap position, or something like that. It's going to ask questions like that. Is this greater than this? Is that greater than that? And it will eventually come up with a conclusion of 1 or 0. So each tree will come up with a conclusion of 1 or 0, and then they'll tally up the votes, and it will make a decision based off what all the trees have decided. So the hyperparameters, what they mean is n estimators is just basically the number of trees. The reason why I have it set to 5, usually you do like 200. The reason I have it set to 5 because this laptop is actual trash, and it will just lag so bad if I set it to like 200 or 100. Like, it would lag really bad. This is fair because you're basically running like 200 trees 60 times in 1 second, so it's going to lag pretty bad. And then the max depth is just, I believe it's basically how deep the tree has to be. So basically the number of questions it can ask, basically. This, I forget what this means. I actually forget. These two, I forget what it means. But random states is just basically, it's like there's different random points, and like I just set it to 42, saying that, oh, if I ever like built the data again, it gives me the same results. So it's not actually random. I'm making it not random, even though it is, but it's not. So it's kind of confusing. But the idea is I can reproduce my data, my results, basically. So we train the data, and then we build the game again. And what we do differently this time is we get the game state. We're actually getting the data again, right? We just return the values that we need in the order. It has to be in the same order as this, or else the machine learning model will get confused. And then we play the game. So this is basically just to reset the game. I made space to like reset the game, but this is actually what happens. So we get the state, we get the game state, and we put it in a variable called state. And then now what happens here is sometimes at the start of the game we have like a create pipes function, and so at the start we won't have any pipes. So, and then without pipes, which is one of the variables that we need, without pipes we don't have a pipe distance, and we won't have like any variables for like a few like seconds. So that's like the first maybe 200 points of data won't have, or maybe first 60, I think 60 or 70 or something around that area, it won't have like any pipes. So the machine learning basically doesn't know what to do. So what I did was, if the state is not none, we get the, like, if there's something in like that variable, then we basically just do like normal predict, and if the predict is 1, we change the velocity to make it jump. But if it's not, it's just gonna hover in the middle for a bit until we start making pipes, and then it will start jumping on its own. That's basically the idea of the whole machine learning. Like, if you want to know more about the whole how the Pygame works and everything, I recommend Kenny Yip Coding. I think yeah, Kenny Yip Coding. I recommend going to his channel and checking it out. If you just if you like Pygame and you're not really interested in machine learning. But if you want me to go in depth into like how the machine learning and everything works, then I could do that. I can make another video, or I can make a short. Just let me know in the comments, and then thank you for listening. If you like the video, subscribe, like, and thank you for watching.